Have you ever looked at a world map and noticed how the coastlines of South America and Africa almost lock together like two giant puzzle pieces? This isn't just a fun coincidence, it's a clue to one of the most important discoveries in Earth science, plate tectonics. Imagine Earth's outer shell, the crust, not as one single unbroken layer, but as a collection of huge, rigid plates. These plates are constantly moving, even though the movement is so slow we can't feel it. They float on top of a deeper, softer, extremely hot layer of the mantle. Heat rising from Earth's core creates slow but powerful convection currents, just like the circular motion you see when soup boils on a stove. These currents gently drag the plates around the surface of the planet over millions of years. The most exciting events happen at the edges where plates meet. These are called plate boundaries, and they are the most dramatic zones on Earth. When two plates move apart, molten rock rises from below to fill the gap, forming new crust. This process creates huge underwater mountain chains called mid-ocean ridges, which continue spreading and shaping the ocean floors today. When plates move toward each other, something even more intense happens. One plate may slide beneath another in a process known as subduction. This creates deep ocean trenches and sparks volcanic activity as melting rock rises back to the surface. In other places, instead of one plate sinking, they crash into each other and push upward, forming massive mountain ranges like the mighty Himalayas, which are still rising even today. There's another dramatic boundary type, transform boundaries, where plates slide past each other horizontally. They don't move smoothly. They grind lock and then suddenly slip, releasing energy in the form of earthquakes. Famous faults like the San Andreas in California are perfect examples of this. Every shake we feel is a reminder that Earth's surface is in constant motion. What makes plate tectonics truly amazing is that this single process shapes almost everything about our planet. It builds continents, opens oceans, lifts mountains, fuels volcanoes, and triggers earthquakes. It even affects climate over long time periods by rearranging continents and ocean currents. Without plate tectonics, Earth would be a quiet, lifeless rock with no dramatic landscapes and no geological events. Instead, we live on a world that is constantly changing, always reshaping itself, and forever full of surprises. So the next time you see a map or feel a tiny tremor under your feet, remember, you are standing on a giant, moving plate drifting slowly across a living planet. If this journey into the forces that shape our world sparked your curiosity, make sure to like, share, and subscribe for more clear and simple explanations of the most fascinating ideas in science. Think about how the coastlines of South America and Africa seem to fit together like pieces of a puzzle. This puzzle-like connection is actually a hint about the incredible process happening beneath our feet. Plate tectonics is the science that explains how Earth's surface is constantly changing. Imagine Earth's crust as a cracked shell made up of large moving pieces. These pieces are called tectonic plates. They move so slowly that we usually don't notice, but over millions of years, their movements have shaped the world we see today. At the boundaries where plates meet, the real action happens. Sometimes plates move away from each other and magma fills the gap, creating new land under the ocean. This process forms underwater mountain ranges called mid-ocean ridges. The Atlantic Ocean, for example, is slowly getting larger because of this spreading process. Other times, plates come crashing together in a dramatic collision. One plate may slide underneath another, creating deep trenches in the ocean floor. This process, called subduction, also causes volcanoes to erupt when melting rock rises to the surface. The Himalayas, which are still growing taller today, are the result of plates colliding head-on. Transform boundaries are another type where plates slide past each other in a horizontal motion. These plates don't slide smoothly. They often get stuck and then suddenly slip. This sudden slip causes earthquakes, which we can feel as tremors or shivers. The San Andreas Fault in California is a famous example of such a boundary. Every time an earthquake occurs, it's a reminder that Earth's surface is moving constantly. What makes all of this so fascinating is that plate tectonics explains so many things about our planet. It creates continents, shapes oceans, builds mountains, and even influences the Earth's climate over millions of years. Without plate tectonics, Earth would be a very different place, silent and static with no towering mountains or active volcanoes. Instead, our dynamic Earth is full of surprises, constantly changing and reshaping itself. So, next time you look at a map, think about the giant moving plates underneath. Remember, you are standing on a living, breathing planet that is always in motion.